In problem 6, we're given a table of values of a polynomial function. And first thing we're asked is how many x-intercepts are there. So the thing about x-intercepts, what we're looking for when we've got a table of values is when the output goes from negative, right, below the x-axis, to positive above the axis. That's when we know between those 2 points there was an x-intercept. Or vice versa. The output is positive, meaning above the x-axis. If the next point is negative, that means at some point between those 2 points, it crossed the x-axis. All right, so let's look for that situation here. And it looks like we are above the x-axis when x is -6, and then we're below it when we're at -5. So there definitely crosses the x-axis here. Next time we go from negative to positive, it's right here. From positive to negative, we got right here. And then from negative to positive here. So there are 4 times in this table of values where there are x-intercepts. So 4 x-intercepts. And in order to figure out which values of x between which those x-intercepts occur, we just look on either end here. So there, here, these 2 right there, and these 2 right here. So that's 4 sets, 4 different pairs of x values. The first one is between x equals -6 and -5, x equals -1 and 0, x equals 0 and 1, and x equals 3 and 4. Those are the 4 pairs of x values between which there is an x-intercept. All right, let's clear that off. Next thing we're asked is how many turning points are there? Now, turning points occur when a graph goes from decreasing to increasing. At some point there must be a turning point, or vice versa, from increasing to decreasing. There is a turning point somewhere in between. So what we're looking now here is not whether or not the output is positive or negative, but whether or not the output is increasing or decreasing. For instance, when the output goes from positive 437 to negative 274, that's a decrease. And it looks like the graph keeps decreasing to negative 472. But then look here, it increases to negative 393, increases again to negative 215, and again to negative 60, and then again to 7.7. Then at some point around there, it decreases from 7.7 to negative 16.25, decreases again to negative 81, but then increases from there to negative 33, and one more increase. Okay, so we've marked our graph with the decreases and the increases. How many turning points are there? Well, we just need to look at where those turning points are. There's one here, right? That goes from decreasing to increasing. Then we've got the reverse situation here, increasing to decreasing. And then one more decreasing to increasing. So I see 3 turning points. And how do we find out between the x values those turning points occur? Well, we actually have to look on both sides of where that turn happens, because we don't exactly know, we don't know for sure that the turning point happens at -4 in this case. We can only know that it happens somewhere between the 2 points that are on its right and left. So somewhere between x equals -5 and between x equals -3. We've got to do the same thing up here for the second turning point, and for the third, we've got to look to those 2 points. So if I were to write out all 3 sets of x values, I would say between x equals -5 and -3 is the first one. Between x equals -1 and 1 is the second, and the third one is between x equals 1 and 3. And that covers the 3 turning points. Okay, what's the degree of this polynomial? Well, we have 3 turning points, and let's take a look at its end behavior. It looks like, its end behavior kind of goes like this, and then on the other end it goes like this. In between, if you wanted to kind of try and visualize what's happening, it's increasing, then it's decreasing, then it's increasing. So it looks like this is kind of a U-shaped graph, and we know that corresponds to an even degree polynomial. Here we have a shape that looks like this, and a shape that looks like that when we have 1, 2, 3 turning points. That's going to be a degree of 4. Fourth degree. Is the leading coefficient positive or negative? Here it's going to be positive, because positive leading coefficient corresponds to the end behavior that looks like this, right? That U shape opening upwards, and that's what we have here.